For this next one, we're going to need a graphing calculator. So what I did is I pulled up Desmos.com. I just typed in Desmos.com. Then we're going to click on the graphing calculator. And we're going to do whatever it says to do. Start by writing your parent function as y equals x. So in Desmos, type y equals x. If you're on a keyboard, you can just use your regular keyboard, and you can see that it already made the graph here. Then what does it say? Graph the function, sketch it, and label it. Okay, well, y equals x is a super easy graph because it goes through the origin, and then every time x moves up by 1, the y will also go up by 1. All right, there's my parent function. What does it want now? Enter a second equation into the calculator by replacing f of x with f of x plus k, where k is equal to 6. Okay, well let's see if something special can work in the Desmos. What if instead of writing y equals x, what if we write the actual f of x? F parentheses x. X. Then let's do f of x plus k. Oh, but they didn't want us to use the letter k. They said k is actually equal to 6. K is equal to 6. So we're going to write f of x plus the number 6. And you can see that it graphed that for you. That one is going to be a green line. So what Desmos did is it knew that f of x is the parent function. It's some function, and it's equal to x. So it just graphed that straight. Whatever x is, y is going to be the same thing. Then for the green part, when we said f of x plus 6, we already defined the original function. So all it did was it took everything on the blue line and it added 6 to it, and it made this green line. What equation did we write? We wrote, okay, so let's just write it. We actually typed in f of x plus 6. And what that means is since f of x was equal to x, then this is really equal to x plus 6. That's what we actually graphed. Because look, these two things are equivalent. And when things are equivalent, you can substitute. So what we did is we substituted, we swapped out f of x for just x. Because those two things are equivalent. We can flip-flop and pick whichever version we want. It's a little bit weird, but if you program, you're going to be substituting a lot of things because you have to define your variables. What equation did we write? We wrote that. Did we explain it? F of x is equivalent to x. And we added 6. We added 6. I guess I can move that 6 a little bit farther out. There. So what we're going to do for this graph is we're just going to take every dot that I graphed the first time, and we're going to raise it by 6. So this first one, we're going to go 1, 2, 3, 4, 5, 6. Second one, we're going to take that second dot and go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and make a new line. What we just did is exactly what Desmos did. It took the original graph and just added 6 to every single number for the y, because the y is the output. So we took the input and added 6 to it. Display the graphs of both. We did it. I guess we could label it now. This orange one was f of x plus 6, and the red one was the parent, which means it's just f of x equals x. Describe the transformation, which means how did the actual picture change this time? Describe the transformation. How did the picture change? The parent function when f of x had 6 added to it, shifted up 6 units. When we add 6 to the function shifted up 6 units. How is the slope affected? It wasn't. Okay, let's do this one using Desmos again. Enter a third equation into the calculator, where f of x is f of kx, where k is equal to 2. So let's just write that down. F of kx, but k is equal to the number 2. Display this graph. So in Desmos, we are going to write f of 2x. All that this is saying is that we're going to multiply x by some letter k. It's not the constant of proportionality this time, it's just k, a constant. So we're going to make a new graph. We're going to type f parentheses x, close it. Nope, just kidding. We're supposed to do parentheses 2x and then close it. And that is a purple line, which we can see right there. It's going through the origin. And if we look over here at our spots, when I plug in 1 for the blue graph, you get 1. Or you can see that whatever you plug in for x, you're going to get the same thing for y. Every spot that the graph can read, whatever x is, y is the same thing. Now if we look at this purple one, let's see if I can get here. When you plug in a half, you're going to get 1. When I plug in 1 for x, it's giving me 2 for y. So what this purple graph is doing is whatever we're plugging in for x, it's multiplying it by 2, and it's giving that for y. Let's even look right here, like 1.31 for x, then it's 2.6 something for y. It's just multiplying x by 2. Describe the transformation. We are multiplying x by 2 to get y. It's really weird, but that's what I was telling you, is that function notation can do some cool things. How this would look as a regular equation is y is equal to 2 times x. That's it. The regular equation looks like that. The function notation looks like f of 2x. It'll make sense eventually. This is just your first time doing these transformations, so it's okay that it doesn't make perfect sense yet, but it will. It's just going to take some time to catch on. So let's draw the original graph. This time I'll just label it y equals x, which is the same thing as f of x equals x. And then the new one was whatever you plug in for x, you're going to do double that for y. This one is the same thing as y equals 2x, which is the same thing as f of 2x. Formulate a general description for the effect of replacing, okay, so this one and this one when doing f of x plus k, what happened to the graph? Between the red one and the orange one, what changed? Was it the slope or was it the y-intercept? They sure look parallel to me, so that means the slope didn't change. It's the y-intercept that changed. Whenever we're adding something outside of the parentheses of the function, we are changing the y-intercept. Period. Whenever we do the other one, which we just did, whenever we put a 2 in the parentheses, that changed the slope. Are there any linear functions where your conclusions in part D do not apply? Yeah, probably. For example, if f of x was equal to 3, that would mean that y is equal to 3. But in the parent function, if I went f of 2x equals, is that going to change it? Is it going to change it? No, it won't, because there's nowhere to plug in for the x. And y is equal to 3. There's no x in there anywhere. X is not there. So if there's nowhere to put the x, then these types of transformations won't work. But what would have worked is f of x plus 2. That would actually work to make 5 as the new graph. And these would both be a flat line for y equals 3 and a flat line for y equals 5. Okay, this has been long enough of me speaking to you all. I think you should be able to do questions 1, 2, and 3, hopefully. Try 1, 2, and 3 for your assignment today and the practice section. If you have questions, ask me about it. Send me a message. Send me an email.